Dear students, in the last session we were discussing about microtomes. We discussed the different the uses of microtomes, what is microtome and what is its use, then about the different types of microtome, what are the main parts of the microtome. So such things we discussed in the last session, also about the sledge microtome and the rocking microtome. Now it's rotary microtome. Rotary microtome is a more advanced version, and it is operated by rotating a large wheel. There is a large wheel at the right side, and when we rotate this large wheel, that will cause the block holder or the specimen holder to move up and down against a stationary knife. Here the knife is stationary and the block holder or the specimen holder will be moving up and down. Means our specimen will be moving up and down, and that will be against the knife. So when the specimen is moving up and down against the knife, the sections are produced. And here the rotation of the wheel, that is also transmitted to the feed screw, which advances in the horizontal plane. Okay, there is a feed screw. So when we rotate the wheel, that rotation, that movement is transmitted to the feed screw, and the feed screw will make the block holder or the specimen holder advance to the front. And this advancement, the rate of this advancement can be controlled by using a knurled button, which is fitted on the side. Okay, knurled button. This is the knurled button. This knurled button we will see also in several other instruments to adjust the movement of a part of the instrument. So also the cutting knife, which is kept stationary, that can be tilted in different positions so that a range of cutting angles are available. And the sections we get from this microtome range from 5 micron thickness onwards. And the thickness of this sections can be set by turning the knurled button. Okay. And the perfection of the sections depend upon the quality of the knife, most often upon the quality and the sharpness of the knife used. This is the image of a rotary microtome. Here you can see the rotating wheel, and just the handle also can be seen. We can hold the handle and rotate it. On the right side you can see that. Also you can see the knurled button there. Using that knurled button we can adjust the thickness of the sections, and this will depend upon the rate at which the specimen holder or the block holder is advancing to the front. The cylinder like structure is the block holder or the specimen holder, and the structure that you see in the front, where there is a slit and a middle part which is open, that is the knife holder. Here in this picture, the knife is not inserted into that knife holder. We can place the knife into that holder and tighten it using the 2 screws that you see at the front. On the right side and left side you can see the screw. By rotating it we can tighten the knife and keep it stationary, keep it tight in that slot. So this is again a modern rotary microtome. Okay, you can see the wheel can be seen, the handle also can be seen, knurled button can be seen, then the object holder can be seen. Object holder, or we can also call it specimen holder or the block holder, that cylinder like structure in the middle. Then at the front you can see the place where the knife can be kept. It can be slided forward and backward, that is the knife holder can be slided forward and backward, and there are knobs to keep it tighten also. At the right side you can see the knob which can be rotated to keep it tight or to fix the knife there. I'll show you the working. You can see here the wax with the specimen at the middle. Okay, that block of wax with the specimen at the middle. So a knurled button is turned to adjust the thickness. This is a section which is containing the specimen. Okay, so I'll close the video now because you saw the working of the instrument. Next is about knives. The microtome should have extremely sharp blades. Okay, and there are different types of blades available, that of steel blades, then glass knives which is used for electron microscopy, then is industrial grade diamond knives used for both light microscopy as well as electron microscopy, and also gem quality diamond knives used for electron microscopy. Next is about ultra microtome. This is an automated machine. Okay, automated machine means it will work automatically. We need not rotate or use a handle to move it. It will move on its own. It is an automated machine and it is used to obtain ultra thin sections for electron microscopy. And here the knives which are used are glass knives or diamond edged knives. Okay, the knives used are glass knives or diamond edged knives. Hence this ultra microtome is a very costly instrument. And here the sections which is produced, that will directly fall into water in a small trough. Okay, where a small trough will be kept with the water, and the sections which are formed, that will directly fall into that water, and they are collected and used for transmission electron microscopy. And these sections can also be used for light microscopy. Okay, and this is a very sensitive instrument. So here since it is an automated machine, then also it can be operated with rotatable handle also. Means when we use this instrument, first we need to adjust the thickness etc. by rotating the handle. Okay, but that is by manual operation. Through manual operation we need to first adjust the thickness and things like that. Certain things we need to set in the instrument. So for that we are using this manual operation by rotating the handle. After setting all the thickness etc., we can put it in the automatic mode so that it will be taking the sections without manual operation.
Alright, today we're going to cover the important points of setting up and cutting thin sections on the ultramicrotome. Okay, our first step to getting thin sections on the ultramicrotome is to place the sample that's mounted into the sample holder into the sample rod.
So in electron microscope, when we take samples for electron microscope, sections for electron microscope, we do not embed it in bags, paraffin bags. We embed it in epoxy resin. So you can see in this video that holder, object holder, which is containing a small black material, that is the epoxy resin which is containing our specimen. Okay, that is the specimen embedded in the epoxy resin.
If we take a quick look at the tip of the sample, you can see it's already been trimmed into a nice pyramid. It's already been thick sections, so that's why it's so smooth on the face of the block. It goes into the sample arm like that. That's the part that moves it up and down over the knife. And then it's important that you remember to...
So in this ultramicrotome, the object holder will be moving up and down, and here the knife is kept stationary.
Tighten it using the set screw that's on the side. Now we need to stick a knife into the knife holder. Here's a knife already prepared with a boat, and that goes into the knife stage.
So this is the knife which is inserted. Okay, it may be a diamond knife, okay, or a glass knife. Most often diamond knife is used, and you can see a small trough which is attached to it, black colored, and in this small trough water will be filled, so that the sections which are formed, that will be falling directly into this water.
Push it up against the forward stop and also against the side, and then you tighten the screw on the knife stage. It's important that the clip, and we slowly add the water. You don't want to go too fast, or else the water will jump over to the back side of the knife and then get on the block face, and it takes a while to dry that back off again. Slightly overfill the boat, so you have a
this is water being filled into that trough, small trough.
As you see here, the knife edge is completely
so
wet.
This is ultramicrotome. What you see, this instrument is ultramicrotome.
Place it into the water, and you'll need to watch through the binoculars or the TV viewing screen.
So here a microscope will be attached to this microtome.
You'll notice,
okay, that's how it works.
That the block face is a little crooked compared to the knife edge.
Microscope will be attached to this microtome. Only then we will be able to adjust the thickness, the trough, etc.
Which will rotate that, and then allows you to get the block face parallel to the knife edge. Now you notice
these are all adjustments being done. Okay, after all the adjustment being done, and after all the setting of the instrument, then we put it in the automatic mode.
A position that we're not accidentally going to hit some other place of the block. Approach slowly and carefully. Use the stage.
I've added this link into the data that I have provided. So you can click on the link and watch the entire video.
Micrometer to adjust. Move it closer. Pass through again. Remember to take a clockwise pass of the flywheel.
This is manual operation.
So now we're really
close. You can see
close
that object holder
and
moving
just
up and down.
To take a section.
And this knife is kept stationary. Here
so
you
now
saw the
here
knife.
It's so close
Here
that really
the knife is very small, very small. Not like in other microtomes. The knife is very small because it is made up of diamond or glass, or most often diamond, gem quality diamond knife is used here. So it is very small.
Can't see it anymore. Now you know that we're just really close, and we'll just take small thin sections. We're going to let the motor do the work. Now the nice thing about this microtome is that it will cut slowly to cut the section and then return to the next cut quickly. But we need to tell it where that slow part is versus the fast part. And that's using the cutting window control on the Microtome controller. Position the sample roughly 2 to 3 block heights above the knife edge and press the upper cutting window button. Then lower it so that you're just below the knife edge and press the lower cutting window button. And now you're ready to cut. I usually start a little bit thick, usually around 90 nanometers.
No, you can see the machine is operated automatically.
And monitor the color of the sections as they come off. Usually takes us 1 or 2 sections before the
sections are being
Microtome
produced.
equilibrates to temperature. We're getting a pale gold colored section to come off. I'm going to make it a little bit thinner. And we're getting a kind of a pale, very pale gold to light silver color. So there you have it. We've cut thin sections safely without wrecking our sample. And now we're ready to pick up those thin sections and put them on a grid.
Next is about cryo microtome. Cryo microtome is used to make sections of water-rich tissues. And here these water-rich tissues are hardened by freezing and then cut in a frozen state. Okay. And here we use a liquid nitrogen chamber for this purpose. We are using a liquid nitrogen. This means freezing the tissue as well as cutting it in frozen state, that is done in a liquid nitrogen chamber. And this is also a faster technique when we compare to other microtomes. And here the freezing of the specimen that will blocks the degradation of the tissue and prevents chemical damage occurring in the tissue. So this is ideal for immunohistochemistry. I'll show you the video of a cryo microtome. This is a cryo microtome.
Welcome to New Life Scientific. My name is Steve.
So what you see here, that instrument is the cryo microtome.
Today we're going to be talking about cryostats, namely the Microtome FE by Thermo Scientific. This is a Shandon model.
This cryo microtome is also known as Cryotome or cryostat.
A venerable name in the cryostat industry. Great thing about the Shandons is that the microtome is not inside the unit, so you don't have the thermocondensation problems when you shut the unit down. That's why you've got that nice straight wall in the back of the...
That chamber is liquid nitrogen chamber. Okay, use what you see.
Cryo chamber. This cryo chamber was just started up a few minutes ago. Not quite down to temperature yet, but it's getting close. Of course, we have the knife holder assembly included. This is a low pro.
Here you can adjust the temperature. You can adjust the thickness of the sections. Everything can be adjusted.
We may be able to come up with a high profile for those of you that prefer the high profile. Waste trays and your side trays, 2 heat sinks. Also included is the rack and 2 specimen heads. Of course, these would typically not be there. Set in, and of course that'll suck the heat out of your specimen head. Fully rotating, articulating head. Unit works excellent. Nice and smooth, very easy. Onto it, nice clean system. Of course, this is the fumigate pan. The Shandon line, all the Shandon line does come with fumigation. It's not an option as on some models. We've got this shown at this. We can adjust this from 60 microns to 1 micron. Temperatures in the cryo bar. You would start your fumigation, fumigate, defrost, cryo bar boost, which will get will accelerate how fast you don't need motorized cut. It cuts with the manually. There you go. This is available in our Cridersville, Ohio warehouse. Thank you very much. Have a great day.
Those slides are specially made for the Cryo tape transfer system. You have to open this packaging, and you can see where it says snow coat. As long as it's not backwards, you have the right orientation, and you remove the protective adhesive, and then throw away the waste. The protective adhesive keeps this coating clean and protected, because that's what's actually going to be transformed by the UV light to allow for the sample to adhere really well. So let's set to the fine adjustment. Right. At this point, we're going to use the tapes that are specially made for the Cryo system. You take this tab that's over the knife, peel off the backing gently. If you peel really fast, it tends to curl. Peel it gently, throw away the rest, and put it over the knife like so, and then roll the tape on. Now to protect your fingers, usually I'll use the end of our brush to pick up the end of the tape so you don't put your fingers anywhere near the blade. It's very sharp. You don't know you cut yourself until it's too late usually. Advance the wheel forward on the fine setting, so make sure you're not still trimming. And what you're going to do is cut an 18 micron slice and pull the tape towards you gently and quickly so that you don't have any tape sticking to the blade, like this. As you pull it off, you should be able to get a nice section that you can put on to the slide, and then roll that section on. Close the lid on the Cryo really quickly. It doesn't matter how long you hold it, but if you just snap it once and release, that shines a quick flash of UV light, and that allows the stickiness on this specialized slide to bind to the cryo matrix and the samples inside. I warm it with my finger really briefly. You don't want to get it too sticky. And hopefully what's left is your cross-section of a tomato stem. I find if you pull really fast, you end up taking the matrix with it. That's not ideal. So this you can either leave in the chamber with everything else and kind of pile them up, or you can put...
This is working inside a Cryotome or Cryo Microtome or Cryostat. Okay, it is also sometimes known as Cryogen.
Put it into a rack for saving in the freezer.
Next is about laser microtome. Here a laser is used which cuts the sections from a sample. Okay, laser is used here. And which type of laser? Femtosecond laser is used instead of a mechanical knife. So there is no mechanical knife here. Instead of knife, there is a femtosecond laser used, and this laser beams will cut the material. Okay, cut the sample into thin sections. What is a femtosecond laser? It is a femtosecond means it is 1 femtosecond is equal to 10 raised to minus 15 seconds. That is known as 1 femtosecond. So a femtosecond laser is a laser which emits optical pulses with a duration well below 1 picoseconds. Okay, that is known as femtosecond laser. So that will emit laser at the speed of 10 raised to minus 15 seconds. So these are ultra fast lasers. Okay, and or it is also known as ultra short pulse lasers, and this laser is used to cut the material. So this is contact free. One main feature is this microtome is contact free, and it does not require sample preparation techniques also. And the slice thickness, the section thickness will range from 10 to 100 micrometers.
Welcome to this, our video presentation. Cutting time for a sample of the size depicted being approximately 3 minutes. This time may be used for the preparation of the next cut, the documentation of samples, or the setting out of histological stains. After the cutting process has been completed, the sample may be removed from the microtome.
So this is a laser microtome. Working of a laser microtome.
The sample is now separated from the section with the aid of pliers. The section remains attached to the slide and may now be stained or simply cover slipped as is, depending on the application in question. Several methods for staining embedded sections have been established for use here. After the entry of a few software settings, the cutting process has begun with a push of the start button. The cutting process will now be completed
This is the cutting
automatically,
process.
with the cutting time for a sample of the size depicted being approximately 3 minutes. This time may be used for the preparation of the next cut, the documentation of samples, or the setting out of histological stains. After the cutting process has been completed, the sample may be removed from the
So
microtome.
here now the section has made. Okay. Now the section has made, but you did not see any
The
mechanical
sample is now
knife moving
separated from the
against
section with the aid of pliers.
You did not see any mechanical knife moving against the sample. But when that plate moved, the section has already made. Okay. The cutting procedure was carried when you saw that plate moving slowly. Now the sample is removed and the slice or the section remains fixed on the glass slide.
The section remains attached to the slide and may now be stained or simply cover slipped as is,
So this is the
depending on the
section.
application in question. Several methods for staining embedded.
Now next is about the applications of microtome. What is the application? It is used to make thin sections of a specimen, and the application depend upon the microtome we are using. In cryo microtome, what may be the application? Thin sections can be taken without contact free. Thin microns of the range 10 to 100 micrometer thickness can be taken with cryo microtome. Okay, so the application depend upon the type of microtome which is used, and overall we can say the application of microtome is to take thin sections of a specimen or of a sample. Ultra microtome can be used to take ultra thin sections for electron microscope studies. And other rotary or rocking microtome can be used to take thin sections for study in optical microscopy. And sludge microscope can be used to take sections of hard materials like wood for observation under microscope. So that is the main application of this microtome. So in cryo microtome, we can take sections of using cryo. What is the application of cryo microtome? We can take the sections of water-rich samples. Okay, water-rich samples can be freezed and then cut using the cryo microtome. And this is since freezing is used here, there is minimum degradation of the sample, so it is very good for immunohistochemistry. Okay, so that is all about applications of Microtome. If there is any doubt, you can post in the WhatsApp group. Thank you.